Okay, guys, 2.2, we want to talk about circles. So if we want to come up with an equation for a circle, we have to be exact with our definition of a circle. We don't want to just say the round thing. So a circle, I'm going to define as the set of all points in a plane that lie the same distance from a given point. That's what we call the center. Otherwise, if they're not all the same, it might be something that looks more like an ellipse, if you've ever seen that. That distance is called the radius. So right here, I'm going to call the center HK, and I'm just going to take some general point, I'll call it XY, on the outside of the circle. And that distance there we refer to as the radius. It's the same all the way around. Okay. So what I'm going to do to try to come up with a formula to represent this is I'm going to use HK in the distance formula as my X1, Y1, and I'm going to use the general point XY as my X2, Y2. Okay, so here's my distance formula. Here I plugged everything in. Instead of saying distance, I'm saying radius because that's the distance we're talking about. And if I make these substitutions, it looks something like this. Okay, y minus k squared. Then to get it in the form we want, we're just going to square both sides. So we're kind of undoing the distance formula a little bit. Okay, and what that gives us is what we call the center radius form of a circle. A circle with center HK and radius R has equation x minus h squared plus y minus k squared equals the radius squared. You're going to want to memorize this, okay? I think it's easier to remember it if you understand how we came up with it. And this is called the center radius form for the circle, okay? So this is the form we generally wanted. It's the easiest to graph, okay? So if HK is equal to 0, 0, so if the center is right at the origin, then we just get x squared plus y squared is r squared, because these both zero out. So just to look at a few quick examples of this center radius form, find the center radius form for each circle. In this example, they say center 2, 3, radius 9. So 2 is my h, 3 is my k. And I'm going to remember that, oh yeah, it's x minus h squared plus y minus k squared is equal to r squared. So our center radius form is x minus 2 squared plus y minus 3 squared is equal to the radius squared. That's 81 in this case. Okay? And the graph for this, just as a quick rough sketch, would look like this. It's centered at 2, 3. So there's your center, and then it has a radius of 9, so it's somewhere way out here. Please excuse my drawing. I'm not so great at drawing. Okay, so there's the first one. The second one, center 0, -1, radius square root 3. Here's my h. Here's my k. X minus h squared plus y minus k squared equals r squared. So this is going to be just, instead of writing x minus 0 squared, that's just x squared now. Plus, now we got to be careful, y minus k. So what is a minus -1 is a plus 1. It always ends up being the opposite sign for this formula. See that? Minus a -1 is really a plus 1. Radius squared, the square root of 3 squared, is just 3. Now, if you want to put this on a graphing calculator, okay, here's the thing to recognize. Suppose we have this. This is centered at the origin with radius 3, this circle. This is an implicit formula like we talked about in the last section, where we don't just have what y is, okay? So in this implicit formula, if I want to get it so I can put it into my calculator, what I got to do is I got to solve it for y. So see what I did here, okay? And then take square roots. But in this case, I do need the plus or minus because it could be above the x-axis or below. So really, you would have to put 2 of these in. You would have to put y equals the square root of 9 minus x squared. This right here should give you the top half of the circle, which should look like this. Okay, and this will be a 3 right here. And you also need to do y equals negative square root of 9 minus x squared. Okay, and that would actually give you the bottom of the circle, which would look like this. Together, you can get the whole circle, but it can only plot one at a time. Okay, so that's how you would do it on the calculator. That does it for this video.